And when you measure a liquid with a pH meter, it will give you either the pH, or you can flip a switch and it will read it out in millivolts. So the reality then is voltage in a liquid we call pH. And by convention, if you find that the solution is an electron stealer, you put a plus sign in front of the voltage. And if it's an electron donor, you put a minus sign in front of it. And then you convert the voltage that you measure with a logarithmic scale going from 0 to 14 and call that pH. So plus 400 millivolts of electron stealer is the same as a pH of 0, whereas minus 400 millivolts of electron donor is the same thing as a pH of 14. And if it's neutral, if it's neither electron donor or electron stealer, then that's a pH of 7. So when we say that cells must run at a pH of 7.35 to 7.45, we're saying cells must run between minus 20 and minus 25 millivolts. Well, that was a wowzer for me. Guess what? Cells need energy to work. That makes sense. Now, by the way, people sometimes get confused with these numbers, because if you take a cell in a petri dish and you put an electrode inside the cell and one outside the cell and you measure across the cell membrane, you'll get about minus 90 millivolts. But hopefully not very many of you have your cells in petri dishes. But in the environment of this body, they're designed to run at minus 20 to minus 25 millivolts. So one of the things that you will find is the characteristic of essentially all chronic disease is that you have low voltage going to that organ.